Yeah, all right?
Yes.
All right. And don't forget, if you got worksheets or anything you need us to deal with, we'll deal with it. All right, now here it says limits with trigonometric functions. Now, when you're dealing with trigonometric function, this is the limit you need to know. It's basically you're doing all the substitution as well. But here are the key that you need to know. It will come from the sandwich theorem. They will give you something like this. I'm just writing them as rule. Limit of x approaches 0. And then they give you sine of x. They got this using the sandwich theorem divided by x. They tell you you must know the answer for that one is 1. So let me put that in the box. Now, even if you're to remember when you take 1 and you write it upside down, it's still 1, isn't it?
Yes.
That means whatever it's in the box, even though it was written upside down, it works both ways. As it is, right side up and upside down, the answer is still 1. You need to know that. You need to know that in advance. Then the second one is this one. When you're given limit as x approaches 0, remember everything is in radiant, and then you're dealing with cos of angle x. Okay, I'll just put it in bracket. The answer equals to 1. Now I'm going to put that in a box. Let me close it. It was saving your videos, the one we're busy with. Okay. Yeah, there we go. So the same one, the purple one, what's in the box, it's actually cos of x over 1 itself. We didn't show the 1 at the bottom. That means even if you write it upside down, the answer is 1. You need to know this. Are we together?
Yes.
All right. But I don't think it's there yet here, because all we need to do in number 1, in number 43, in this number 43, all you need to do, just substitute the values there. It's going to be 2 sine of 0 minus the 1, and you get the answer. We good, right?
Yes.
Don't forget, you work in radians. You work in radians. We good, right? Put your calculator in radian, and then you just press 2 sine of 0. I think it's going to give us 0 minus 1, and the answer is minus 1 here. Now, let's go for this one here. How about this one here? Now you've got limit x approaches 0. You have the sine squared. Now remember, I gave you when you're approaching 0, like this one, you got this one, these two here. I can actually show it. Let's do it differently. All right, let's go to the first one. Let's go to the first one. Let's go back to this one here. If I were to create sine x over x, I would require to put x at the bottom and also to put x at the top. In other words, watch now. So I want what's in the box to look exactly like that one. What's missing is x at the bottom. So that means if I introduce x at the bottom here, I must introduce x there to zap it out. Can you see that?
Yes.
Good. So what's in the green, we already know is 1 when you work out the limit of that one. So which means I've got 2 times x, which is actually 2, times, what is the x? It's approaching 0. We put a 0 there, and then times Where you've got the green, we know is 1, then minus 1. All of that is 0. And then your answer becomes -1. Do you see it?
Yes.
All right, good. Because in case they don't, like they say, don't use a calculator or whatever, because those are special angles. But even with a direct substitution, I get -1. All right, so let's go to 44. 44, I want to do it in the same manner, because you might say, okay, what is sine squared? I'm going to break it apart. I'm not writing steps. I'm going to write it as, it's actually sine of x multiplied by sine of x. Do you see that? Because it approaches 0.
Yes.
So what's in the box? That sine x over x. I want to reproduce it. Let's go for the purple. For the purple means if I put x here, I must put another x to get rid of it. Am I correct?
Mm-hmm.
Then the box is 1. How about the red one? Same story. If I put x here, I need to counterbalance it, put another x there. Allow me to put it way there at the back there. I'll put it here by the red. Then everything in the boxes, they are actually ones. So I just substitute x. X is 0. Yeah. So that means for the first red one, I'm going to have a 0 times by the next one 0, then times by 1, then times by 1, then the answer is 0. Even if we were to substitute here, you'll get a 0. Is it making sense?
Yeah.
Oh, you lost. You lost.
No, I'm still trying to process.
All right. Let me show you something. Let's go back here. All right, let's do this. Let's say you've got 5. You know 5 equals to 5. Am I right?
Yes.
There's 2 ways I know of to keep that statement true. I'm talking about if I'm using addition and subtraction. One way is this. If I plus 1 here by the right, I must also plus 1 here. If I'm looking at both sides, the statement is still true, correct?
Mm-hmm.
That is for addition. But did you notice that you could have transposed the 1 here to make it minus? So meaning, instead of adding on both sides, why don't you add 1 here and resubtract it again? There we go. And then, but don't cancel the 1 and the red and the yellow. Don't cancel them. Ignore them. Work with the other one and say, this is the same. You'll say, this is the same as 6 minus 1. 6 minus 1 is the same as 5. Can you see that?
Mm-hmm.
So with addition, you can add on both sides or subtract on both sides. That is looking at both sides. But if you're looking on one side, you can add on that side and subtract on the very same side. Actually, you saw this one when you're doing completing the square. Completing the square, they say take half the coefficient of x, add it, and subtract it again.
Yes.
Yeah, it's to neutralize. Now,
Okay.
when it comes to division, if I've got 5 over the 5, all right, to keep that statement 5 over the 5, I can use multiplication. That means if I multiply the top by the 2, I must also multiply the bottom by the 2 to neutralize it, because it's like they cancel those guys, but you don't want to cancel them. Can you say that?
Yeah.
So if I don't want to cancel them, maybe I say I want to partner that with that, partner that with that. That's one way. Another way, you say I look at the top and bottom, 2 different sides, like left and right. What if I was only dealing with one side? I could have just said, well, I can just multiply the top by 2 and divide it by 2, meaning multiply it by half, neutralize itself. Can you see that?
Mm-hmm.
Good. That is the same. So what we are saying if I've got sine of, let's put the angle there, it's 5 theta. They gave it to you as 5 theta. It's over the 1. You wish, let's go back what I was showing you. You wish you had another value here or factor that is equals to the angle. You want to reintroduce it because you know it's 1. So your wish was, man, I wish there was a 5 theta here, because if these two are equal and I'm dealing with x approaches 0, it's a 1. Yeah. So you reintroduce it because it's basically like saying you're putting 5 theta there at the bottom. Then put another 5 theta at the top to neutralize it. Then you've got what you are looking for. You got what you are looking for. That. Can you see that? You know the box is 1 now.
Yes.
Instead of saying let's cancel, because you're just going back. That's the idea. Even if it was at the bottom, let's say maybe you had 7 divided by, let's say, sine of 2 theta. Your wish was, oops, I wish I had 2 theta right at the top. So go put it at the top and also put it at the bottom to neutralize it.
Yes.
Yeah, then this is 1. Then you've got 7 over 2 theta times the 1. Then you can substitute the value there. I hope you got it. You got it, right?
Yes.
Yeah. All right. You do that where there is sine all the time. Sine theta. But when you've got tangent, you must change tangent to sine and cos, because we know the cos one. Yeah. All right. So that sine squared, the rule that you have that says sine x sine, it's not squared. So you want the sine which is not squared. So what I did is this one. Let's write the sine not squared. That means I've got 2 of them. The first one is sine x, and then times, I'm making a nice space there, times by the sine x. Do you agree? These 2, though I space them, it's actually sine squared, isn't it?
Yes.
Good. But when you look at the box, you want the sine which is not squared. Well, the purple is not squared, the red is not squared, but on the purple, you wish you had the x at the bottom. So go put x at the bottom, neutralize it there at the top. So in the box, you know it's a 1. But you could do the same thing with the red one as well. Can you see that?
Yes.
And then you go put x at the bottom, you go neutralize it there by putting another one there, and then you've got that. So wherever there is a box, they are all 1. But in place of x, you are to put 0. So I've got the first purple x where I need to put 0. The box is 1. I've got the red x, I must put 0. I've got the box, which is 1. Then when you multiply all of that, the answer is 0 still. Did you get it now?
Yes.
Yeah. Remember the angle in the sine, whether it's 2x, 5x, whatever it is, you must have the same thing at the bottom or at the tops in order to get 1 if it's approaching 0. Maybe I went too crazy, but it's fine. But, yeah, but you got, because they'll make you, this one, it's solved using the sandwich theorem. They actually prove it with the sandwich theorem using the area. I'll show you that. All right, so I want to do this, and then, all right, let's look at the tangent. Here's the tangent now. So you can just direct substitute and press tangent of 0. Well, I know it's 0, but let's convert that. We say, no, tangent, I'm going to write it, this must be limit. It's always when it's approaching 0. Then it has to be sine of x over cos. All right, so all over the cos of x. But remember this rule here. You wish the sine was standing on its own, the cos was on its own. Remember, I said even the inverse of these rules are exactly the same. Remember, right?
Yes.
All right. So I'm gonna spread out this formula. I'm gonna write it right above there. So I'm gonna spread it out. So I'm gonna write it as this is limit as x approaches 0. And then the sign, I'm separating it. I'm giving it a nice space. It's going to be sine x alone. I know it's like over 1 there, times the cos, when I spread it, is 1 all over cos x. Yeah, there we go. The one that demands to have top and bottom, the angle is a sine, the red one. Good. So that means if I introduce, because I don't really need that one. Let me remove it. Yes. If I introduce x here, I must neutralize it there. Yeah, there we go. Then that one is 1, isn't it?
Yeah.
The
x.
Oh, yeah. This x is 0. The box is 1. The cos, it's fine. It does not demand another x there. It's fine by itself. It's 1 even if you write it upside down. You see that? Yes. So which means we've got 0 times 1 and then times 1. Then the answer is still 0. Even when you punch in the calculator, change of 0 is that. Okay. Let's see if there was another one. Yeah, let's look at this one. No, there is a secant. Let's go for the secant there. They call it an ant which is sick. You know that?
No.
It's like a sick ant.
Oh, yes.
It needs a doctor. Sick ant. All right, secant. Do you know how to write the word cosec?
Yes.
I write cosec with a double letter S. That purple letter S is not supposed to be there, but I write it cosec like that. Then I split them into 2. When I split into 2, I know cos and sec are inverse of each other.
Oh.
Yeah, I say cosec with double S. So, so I know. So this one here, it's basically 1 over cos of x, and x is approaching 0. So it's the same as the previous one. If we write this upside down, it's still going to give us 1. The answer will be 1. Can you see that?
Yes.
In the calculator, okay, I'm just going it with the degree. You want to press 1 all over the cos of 0 equals to, there it is, it's 1. All right, so that one is done. So let's look at the case. There are other ones where you find that you don't have a 0 here, and then there's a way to manipulate it. Remember when I said pretend the arrow is an equal sign, but they won't teach you that. They'll just tell you this is how you do it, but you won't understand. But once you get that trick I taught you about, pretend the arrow is an equal sign, it makes life pretty easy. All right, number 47. Number 47, we're still approaching 0, so it's fine. So somehow I need to separate that. So we can individualize those terms, meaning we can have 1 over 3 cos, x over cos, and then sine over the cos. You remember that?
Yes.
Yeah. Because if you've got A plus B and then plus C all over 5 is the same as writing A over 5 plus B over the 5 and then plus C all over the 5. We good, right?
Yes.
All right. We are on the same page. I'm happy. All right, so I'm going to do that now. So that means we have 1. I'm not writing the word limit because we understand that word limit, it is there. We know that. So it's going to be
Yes.
cos of x and then plus x over 3 cos of x and then plus sine of x over 1 time. It's over, but I'm separating like how we did last time. Over 3 cos of x. We good, right?
Yes.
Let's start with the sine. The sine is the one that needs x and x. So I introduce x here. I go put it right at the top there. So this one is 1. Can you see that?
Mm-hmm.
And then this one here, I'm going to put it in green. 1 over the cos there in the green. It's also 1, isn't it? Because it's an upside down of that other one. And then also, all right, so because maybe I could have spread this one out, or maybe I can just say there is a 1 like that and put that over there and say 1 over cos, that one is 1. Can you see that?
Mm-hmm.
And also that one is 1. So that means what I can do for the first one, because the 3 is at the bottom. So I basically have 1 over 3 times the 1. Is it making sense for the first one?
Yes.
All right, good. Because that over 3, there's a 1 that goes with it. You cannot just say over 3. Over 3, what's at the top? Must be 1. Then plus the next one, here we're putting 0 by that x. So it's going to be 0 all over the 3. And I'm timesing by the 1 of the cos. Then plus we got 0 for the x, then next to the sine. Then times by the 1. And then times here, it's a 1, so it's 1/3, and then times by the 1. And you just do the mathematics. The first part here, it's a third. This one will be 0. This one will be 0. So the answer must be 1 all over the 3. We good, right?
Mm-hmm.
Let's test it and see. I'm gonna work with the what you call with the degree. So it's 1 plus in place of x, I go put 0 plus sine of 0. I go to the bottom, 3 cos of 0. 1 over the 3. Can you see that?
Yes.
Yeah, that is if you're doing it without the calculator I was showing you there. All right, there we go. All right, so let's see. All right, so you would have done the same thing here. Here, it's not a problem. You make it into terms. Multiply that with that, multiply that with that, that with that, that with that, so that you have terms spread it out, like how we spread it out that part.
Yes.
Into terms, yeah. And it's 0. All right, so, okay, let's just write those terms quickly. Then I'm having 2x squared and then minus the x squared times by the cos of x. The next one is going to be minus 2 plus the cos of x. Remember, the limit is approaching 0. Am I right?
Mm-hmm.
So the cos x by itself, that one, is 1. That one in the box, it's also 1. The rest, we just put zeros. The 2x squared, there is 0. That one is 0, destroying this one. So the first 2 terms give me 0. Then I've got minus 2 plus a 1, which is minus 1. So the answer is minus 1. Now, let's verify that. I'm opening the bracket. I'm going to put 0 here. So it's going to be 0 squared and then minus the 1, close the bracket, open another bracket, let me say times, open another bracket. Then I've got 2 minus cos of 0, close the bracket, minus 1. You see that?
Yes.
Okay. Let me deal with the last. Now, remember the rules that I gave you. Let me draw the arrow pointing up and down, meaning you can write that rule upside down. So this one here, okay, it's say 10 minutes. Limit x approaches 0 of cos of angle x. It's also 1, whether it's standing right side up or upside down. It only works when it's zeros. What if it's no longer 0, like this one here, number 49? Yeah, like number 49. How would you do that? You wish you had 0 there by negative pi. So here comes that method I taught you, the trick one. That method says, if I were to pretend this is equal sign, if I were to bring this stuff over here to the right-hand side, that means I would have x plus the pi equals to 0, meaning approaches 0. Do you see that?
Yes.
It means what originally we called x, that angle. That means this pi, yeah. That x plus pi. Just call it theta, something, substitute it. Just do it. I'm going to say, let theta equals to x pi theta. So that means it's approaching 0 because the x plus pi, it's actually equals to 0. It approaches 0. Do you see what I'm saying?
Yes.
Good. So remember, I've transposed it to the other side to replace here by the limit. So my new limit goes like this. I've got limit. Instead of putting that x, you put a theta or x plus pi. The choice is yours. So I'll say theta approaches 0. But I must make sure wherever there is an x plus pi, because it will be there, because can you see it's there? Can you see it?
Yes.
Good. Then it's going to be square root of, I'm going to come back for that x. I'm keeping this as 4. So you know you're multiplying this by cos. It is now what? Theta. Good. Now this little equation, the one you said let, you can remove that x. It's like K method. The only letter that must exist is a theta. So from here, from this little equation here, you can actually transpose the pi to solve for x. Can you see? X is theta minus pi. Do you see it from here if you transpose? Yeah.
Yes.
So that means underneath, I'm going to have theta minus the pi. Now you're good to go. Everything is 0. Can you see? It's back to 0. So whenever it's not 0, you transpose it to the other side. You make it 0. That's why I gave it this rule. They work with zeros. And then you say, what if it's not 0? You make it 0. You make it 0. You transpose it. So now we know this one here. It's actually the 1. We know that one is 1 for sure. How about the other one? Well, just go put 0 by the theta and by the pi. That means I'll put 0 here. So I'm left with the square root of, I want to write it as 4 minus 4 pi times 1. This will be the answer, like that, square root of 4 minus pi, or square root of negative pi plus 4. Do you see that? Yeah, and you're like, how in the world did I do that? So, on the same note, okay, let me clear this. If they gave me limit, and then they say x approaches, let's say minus 3. That means, and then I'm having sine. Let's say I've got sine of something. Sure enough, there will be an x. Remember when you transpose, an x plus 3 will be there. I triple dare you. Maybe let's say plus the x. You're like, but this rule for the trig, they work if there's a 0. How do I make this 0? Transpose this to the other side. So that means I've got x plus 3. Somewhere else, you might need to take out a common factor to see the x plus 3. It might be hiding itself.
Yes.
It might be 2x and then plus the 6. When you common factor, x plus 3 will show up. So that's why I told you when you transpose there by the arrow, it tells you what must be there. So now if you make this one equals to any letter, theta, then I know I'm going to put theta here. And then this will be approaching 0. But you say the x must go. So when I solve for x from here, so x will be theta minus the 3. So down here, it will be theta minus the 3. All right. So here's what we got now. And then I think we've got sine of theta. And then way far, we've got plus theta minus the 3. Remember with the sign, I demand something that looks like theta at the bottom as well. Theta,
Yes.
and then times the theta. So the box is 1. And then I just put 0. So I've got 0 times 1. And then plus what? 0 minus 3. So the answer becomes what? Negative 3. Do you see that? Yeah.
Yes.
So you see, they'll start by giving you the nice one with zeros. Then later they remove it. You'll be like, but I don't have a rule when x approaches a different number other than 0. All right. So that one, yeah, those ones, I think they're going to come.